We're going to start.
Give me a sec.
Apologize for the delay. I was about ready to throw that guest badge reader thing through the window out there. Get it to work. Anyway, someone's going to hear about that tomorrow. I'm going to try and do some real quick things. Who's going to Silicon Valley Code Camp? Keep your hands up. I need to see who you are.
What was the question?
Who's already signed up to go to Silicon Valley Code Camp in October? All right. You guys need to come and see me to get one of these really cool, as Peter Keller in the front row tells me, not a sticker. It's a mule skin. They're very special to go. You didn't tell me why it's special. Oh, because it comes off and it doesn't ruin it doesn't trash your important laptop. Yeah. So if you're coming to Code Camp, or if you're willing to look me in the eye and say you're going to sign up tonight, come by and get one of these from me. And if you want to learn more about Code Camp, you should talk to the guy who started it all 7 or 8 years ago, Peter Keller in the front row. Woo! All right. So I want to thank both our, how many Java user group members do we have in the audience? Awesome. How many Google Developer Group members do we have in the audience? It's okay if you raise your hand twice if you're both. That's what I thought. You got a lot of overlap. Okay, or maybe it's just a subset of our 5,000 member GDG that's also in the jug is here tonight. All right, anyway, thank you for all coming. I'm actually wearing the old GTUG logo because this is kind of a special meeting in that we started the whole GDG movement with a joint Java user group meeting that Kevin and I ran over at the main campus to be the very first meeting of what we called Silicon Valley GTUG, Google Technology User Group back then. That was over 5 years ago. So this is kind of a blast of the past, having a joint meeting again. Only this time it's the younger sibling that's now grown up to be able to beat up the older brother. And now that we're 5,000, we reached the 5,000 member mark, right? Yeah. You know, so you jug guys got to get working. You're only at 3,300. So, nothing wrong with that. Anyway, I know we're really late, so I want to get this going. I did want to give a shout out to Paul in the front row, who's been our Google Developer Group photographer for forever, since the beginning. Paul's leaving the area, so he came out this is his last meeting, so we really appreciate his help. And if someone has photography skills or would like to be doing things like with blogging about our events or on Google+, talk to us about that. We'd love to have people helping us share what we're doing here. I put on the Meetup on Twitter and on Google+, the YouTube link. So make sure if you have friends, I'm sure you're going to think this is a great talk by Hans and you're going to want other people to see it. So share that link with them. And I'm going to stop talking. Is there anything I need to say? Turn your phones off. Turn your phones off. And remember, turn them on when you come back. And let's we're very fortunate to have Hans here all the way from Germany, so give him a big hand.
A little higher, yeah. On your collar would be good. Yeah.
Fingers from the water. One challenge after the other. Okay, good, cool. It's good. Yeah, welcome to this talk which tries to bridge, people who have an interest in Android and people who have an interest in Gradle. So my first question would be, who of you is doing Android development? So, and who of you is mostly here to learn about Gradle? Okay, so I once gave that talk at a Java Enterprise conference. I thought, hey, this is a really hot topic. And I was asking who's doing Android development, not a single hand. I was like, yeah. So this is a really nice mixture. And the other interesting thing I found out, initially I wasn't aware, at least in Europe, how separate those communities are. So I was talking with them, how excited we are about the Android story, and then they were saying stuff like, oh, yeah, we think Android will become important. I said, well, you think so? Yeah. So it's interesting experience to see, although it's Java-based, that there are at least in quite a few areas of the world, pretty separate communities. So, and I'm excited that we have a really nice mix here. And yeah, so let's start. What is Gradle? So, so Gradle is a general-purpose build and automation tool, and we see two axes to describe where we want to go and where we are. So one is the horizontal axis; it's the platforms we are already covering or are going to cover in the future. So it all started with Java, and Ruby, Scala, now Android. We're working with high intensity of world-class C++ support, which will then also be interesting for improved NDK support, right, from an Android point of view. We have decent support for JavaScript, iOS. We have some wrapping around Xcode, .NET, not so much yet. So that is the horizontal axis where we want to, where we just want to appreciate the reality that the software stacks nowadays they are heterogeneous. Right? It's no longer, in the old days, people were thinking, heterogeneous software stacks are kind of legacy burden. We all know the software stacks of the future are heterogeneous, and the build and automation tool has to embrace that fact and has to be able to make all those platforms first-class citizens. And not saying, okay, I'm a Java build tool now, let's somehow try to squeeze C++ support into it, right? So it has to be open for that. And Android is a really nice example how open the Gradle platform is. And we talk a lot about that. So the other axis is what we call beyond build. Yes, originally we have build tool, but so compiling and creating the archives. But then we've had a lot of functionality for interesting testing scenarios, interesting integration testing scenarios. We now added features, for you can use your local Gradle build and use a build farm to distribute your integration test across that build farm. Dependency management is another very important topic. We will talk a little bit about that later on. Configuration management, deep CI integration, the whole promotion and releasing and staging of your software, and finally the provisioning. So all those areas, Gradle plays a role, sometimes by integrating with other tools, sometimes by natively implementing that. So just to give you an overview, right?
I'm really sorry to interrupt.
Yes.
Someone's playing on the back now. They can't hear you in the back because even when you're mic for the live stream,
Yep.
this is the mic for the auditorium, and it's a little bit sensitive. So
Okay, so
if you're a little bit closer to that, they'll get the people back there to hear you. I'm sorry about that.
no, that's not. It's good that you mentioned that. So usually people complain that I'm speaking too loud, at least at home.
Is that okay in the back now?
Okay.
Okay.
So
Thank you.
although it's our challenge to see the screen, I will figure that out. So.
Sorry.
Is that okay in the back? Excellent. Okay. So and to give you an overview of where Gradle is, so let's say before Android. So Gradle is used in for quite a while in massive production builds. LinkedIn has fully switched, or mostly fully switched their stack to Gradle. Many other companies, major financial institutes, one of the biggest investment banks is using that for 5,000 of their developers. This is not boasting, it's just to give you an idea of where we are coming from. Before then, the Android team made a decision, hey, let's use Gradle. So Gradle is a well-established technology in many areas. We had a couple of weeks ago our first conference, the Gradle Summit, here in the Bay Area. We have another one in London at the end of the year. There are now more and more books coming. So that is basically where Gradle is. And then we got really excited that Gradle is going to be the new Android build system. So what exactly does it mean? Initially people thought, hey, Gradle will be used for building the Android SDK, but that's not what this is about, as most of you know. So it's a combination. It's basically Gradle plus the Android Gradle plugin that is maintained by the Google Android team. It's not maintained by us. They are developing that in close cooperation with us, plus IDE integration, very important piece of the puzzle. Most of you have heard about Android Studio. So, and that is by itself very exciting. But what is also what is also very exciting for us is that in cooperation with the Android team, we think it is a showcase for a state-of-the-art build system for any domain. There are really cool features we think should be developed the same way for other platforms. I will talk about that during my talk. Okay, so what is so exciting about that new build system, in my opinion? So one thing is it is heavily declarative. What does it mean, declarative? You all know, and I guess you all know Maven. So an imperative build system is basically where you, like an AND, in your build script, you write the target and then you execute this target, right? So you basically, the build author has the granularity of the executional unit. That's how you model your build. You use the executional units and link them together, and then you execute them, right? And a declarative build system is a different animal. The build author does not necessarily work on the executional unit level. So, but the build author can use many abstractions from which the executional units are derived. Let's give an example. So, oops, sorry. So, now, this is a very simple Gradle build. It's empty, and if you now go to the command line and ask Gradle, hey, what can I do with this build? It will tell you there are a couple of built-in tasks. There's a setup task where you can generate a template project. There are tasks you can watch dependencies and stuff like that, but no domain-specific tasks, right? You could now do it the end way and specify the tasks you want to execute, but when we say it's a declarative build system, we mean that you can do something like this. You're saying, hey, Gradle, I want to build an Android project, right? And then you specify a couple of more properties like the SDK version and the build tools version, and that's it. With those few lines, you can now go to Gradle and say, hey Gradle, what can I do with this project? And there's now quite a lot that you can do with this project. You can assemble it, it means building the SDKs, you can install them to a virtual device, you can uninstall them, you can run all the instrumental tests, etc., etc. So you didn't need to specify those executionable units, and you would have to specify each one by one, right? Declarative means you add an abstraction that automatically creates those executional units for you. And Android is interesting because Android projects, even simple Android projects, are much more complex than a simple Java project. This complexity is hidden to some degree. So if you now ask Gradle, hey, show me all the tasks, all the executionable units that are added after having applied the Android plugin, you see there's now a lot going on, right? It's like the IDS stuff, render script functionality, all the resource processing, etc., etc. Android is a very complex workflow, right? Simple line and then ProGuard stuff and then yeah, you all know that. So and one thing Gradle tries to do is to hide as much complexity as possible for a normal Android developer. So that is what we think are the normal lifecycle phases. And usually you're not interested in executing the zip-align task by itself, right? So we could now say, Gradle, hey, build everything, and boom, everything is up to date because I tried it out before. And what you end up with is now all the APKs that you have specified. So let's go back and let's think a little bit of how this works. So how could Gradle just compile that build? Well, the Android plugin is making a couple of assumptions. Right? It's making, for example, an assumption: where do you put your main Android code? What I mean with main code, I will talk about a little bit later. So and if you stick to the assumptions like they live in source main Java, in source main assets, in source main resources, and the Android manifest XML is here, then you don't need to specify anything of where your code lives. When you put your tests in source instrument test, they will be automatically executed. The same is true for the output of the build. If you're now going to the build directory, you didn't need to specify where to put the stuff. So you could have a look at the APK directory, and here you go. There you see all the APKs that are built by Gradle. It's all defined by conventions. Okay. So so that is one thing that I mean with declarative. People who know Maven kind of get the idea, right? But this is a declarativeness that you say, this is an Android project. There's a certain rigidity in it. There's this saying this is an Android project is what we call a project level element and tells a specific story. And the interesting thing with the Android plugin is that you have many ways now to customize that story. And what the Android folks did, they created a language that allows you to elegantly customize typical variations of Android applications and Android libraries. So, for example, they introduced the concept of a build type. What is a build type? A build type is an abstraction that controls how an app is built. So, for every build type, you can specify additional source code and resources. So, the main code base is used by any APK that is produced. And now you can additionally specify source code that should be only used for this build type or for that build type. The Android plugin automatically by default adds a debug and release build type. And for example, the debug build type automatically use the debug signing, right? And of course the release build type is not doing that. And you can specify different program options and things like that. So there are two default build types, but you can define your own build types. One example would be Dick Wall from the Scala community. He's really interested in getting in using Scala for Android applications. And one problem he has, he always has to ship the Scala library with an Android application. And what he would like to do is to make it small. Of course, he wants to use Proga, right, to really shrink it. But doing this during development really reduces the performance. So what he would like to do is he wants to stick with the debug build type that is not doing any Proguard, and with the release that is doing the Proguard stuff. But he also wants to introduce a staging build type, which is then used by the QA folks, which does all the Proguard stuff, but still has the debuggable flag and the debug signing activated, right? So that the QA can work with an APK that is very close to the production APK. That is the stuff you can do with different build types. So if we look at an example, so here you can see another basic Android project, but we do a little bit more here. So we, for example, define some signing configuration that should be used by the releasable APK. We also define an additional build type with the name staging. We additionally configure the debug build type that was added by the Android plugin. And then we also specify the test build type. We tell the test task, hey, use this APK, the debug APK basically, for running tests. We could easily parameterize that we say on the local machine use the debug build type, on the CI machine use the staging build type. So, if we now go to this project, we can say, hey Gradle, what can I do with this guy? And you now see all the stuff. Oops, that's not very. Here. Okay, no, it is okay. Sorry. So, yeah, I missed that. So there is an assemble staging task, an assemble release task, an assemble debug task. There is an install staging task. So what you get when you define this guy here, this is a little mini framework that you apply. You say, hey, I have a staging build type. And that triggers a couple of stuff. First of all, it means you could now create a source directory, source staging, and it would be automatically picked up and put into the staging APK. And it creates a little life cycle for all the stuff that is related to the staging build type, right? You can assemble it, you can install it, you can uninstall it. So this is what we call a dynamic declarative element. And imagine you would have to write this here with and I will bring another example for that soon. So this is one concept that was added to describe a variation of an Android project. And now another important concept is product flavor. So this is a way, as written there, to generate several versions of the same app. So you might want to have you have an Android application that is almost the same with some variations for the free application and the paid application, right? And this is a really flexible context. So you can, for example, not just add specific source code and resources to the free and the paid application. You can also add different kind of dependencies, and you can also add different kind of check rules. You could say you could add a plugin to all your Android applications, the Gradle plugin that says for all the free versions of the free product flavors of my Android application, do a check whether any of the custom dependencies of that APK is commercial, right? So you can customize other app parameters like the target SDK version, signing info, package name, and things like that. So let's look at an example. So here we have added two product flavors. One is called free, the other is called paid. And you see there is now an optional source free directory, which will be added. The binaries will be added to the free APK. There is, and you see you can also easily add test just for the paid variant, for the paid flavor, by following a simple convention. Call your directory source instrument test paid, and it will automatically be picked up and being tested. That's one of the nice things with the Android plugin. You don't need any separate project for your tests, right? So tests are part of the same projects. The Android manifest for the test package is automatically generated. You don't need to bother about it. It just works, right? So, and if you think now what it would take to write an Android build that covers all those requirements, that would an Ant build that would be quite a few lines of code. So have a look at this guy and see what you can do. And you see there is now, of course, some Cartesian product, right? You can assemble the free debug version, you can assemble the free release version, the free staging version. You can also say assemble free, which assembles all the different variants of the free version, debug, release, and staging, right? And at the same time, you can also say assemble staging, which builds the free and the paid version for the staging build time, right? And and the same is true for the tests. You have a sample paid test, you have a sample free test. Usually, you don't need to bother about that. That is happening under the hood, all the test execution, and so that way you can very elegantly deal with the very typical use case that you have slight variations of an application. So who of you was using or is using Maven for Android development? Who of you is using Ant for Android development? Who of you is using no particular build tool for Android development, just the IDE? Yeah, okay, thanks. So, and And I mean, if you look at that, if I would do here a Gradle task dash all, I would get quite an explosion of tasks, you know, hundreds of tasks. Right? I don't need to bother about that, but if I had to do this with a non-declarative build system, there are quite a few tasks to define, right? Like with AND. If I would do that with a declarative build system that doesn't have this model, this flexibility, I would be kind of stuck. I would possibly need to create a separate project for every variant. A project for my main code base, a project for my free code base, for my release code base, for my staging code base, additional projects for the testing of the main code base, for the testing of the free code base. You get the idea. I have a pretty simple Android application with some variants, and I end up with 40 or 50 sub-projects, which is kind of ridiculous. So, and we already used the terminology. So one thing the Android plugin is introducing is the concept of a build variant, right? You have different variants, right, as we described. And there are rules to manage the resource overlay. So you can override code and resources of the main code base, right? And flavor wins over main, and build type wins over flavor. So, but there's even more flexibility and power. What if you have multiple build flavors in terms of multiple dimensions of build flavor? Let's say you have a free and a paid version for the different build types. Now you also have different versions for ARM and Intel processors, right? And that's where there's also the concept of a product flavor group, right? So you can add basically as many dimensions as you want, right? So you can have a free and a paid version, and then x86 and ARM, and yeah. So you have now an additional, you know, a more complex Cartesian product, but it's all very manageable because you have the proper abstractions to deal with those, and you don't need to deal with the implementation details to build all those and to test all those. Let's look at an example for those. So, yeah, here we have something a little bit more abstract. So we introduce here the flavor groups, group 1 and group 2. And the flavor group 1, the F1 flavor belongs to group 1, the F2 flavor belongs to group 1, so that could be paid and free, and the flavor group could be version. FA and FB could be ARM and x86, and the flavor group could be ABI or something like that. And if you now go to this guy and you ask, oops, what can I do with this project? Yeah, there's now quite a bit. You see all the different things you can install, but the good thing is you always have aggregating tasks, right? You can say, hey, just build me every ADK, right? Or build me every debug version of all the different flavor and combinations, F1, FA, F1, FA debug. You get the idea. So there's also a library plugin to support library projects. As part of this new build system, there is a new format for Android libraries. It's called AAR, right? And so it produces Android library bundles. You can upload them to any Maven or Ivy repository, and to contain the compiled code, resources, and then additional program rules and stuff like that. So and it's a first-class citizen, so you can easily have dependencies, you know, from an Android application to an Android library, and of course Gradle knows what to do with that dependency. So what we have here, what the Android plugin provides to the Android developers is a rich model. And so instead that you have to think, how can I implement the Android requirements with the concepts of the build system? For example, in AND, how do I have to create all the targets? Or in Maven, how do I have to create all the sub-projects? it provides you a much better way. It provides you the language of the solution space. You can just say, hey, this is how my Android project is structured. It should look like, right? Those are the flavors, and the rest is figured out by the build system, which is a much more efficient way to solve such a problem. Right? Much lower learning curve, and much better maintainability, much better usability. So a rich model has many advantages. We will talk more about the advantages later. But so you have even pretty complex scenarios like this multi-flavored application I've shown you that would take thousands of lines of end code. You can describe with, I don't know, with something like 30, 40 lines. Right? So that's one of the things I really like with the Android plugin, that they are pushing this concept of a rich declarative build system that models the domain, to a state that is very, very convincing. I'm very, very excited about that, because I think that's how a build system should work. It should provide your language of the solution space. Of course, this is all highly customizable. If you have some special requirements, you can create any low-level custom Gradle task and hook that into your lifecycle, right? Whatever you want to do. Okay, so one other thing that is very cool about this, I think, about this new build system is that it's now also a base for Android-specific plugin ecosystem. So Gradle has a rich plugin system, and the Android plugin is what we consider a base plugin that has no implementation aspect. It's just a semantical thing. It's a base plugin. It's the core plugin for a specific platform, for the Android platform. Now, other plugins like the DroidCon plugin or other testing providers, they can now write their own plugins that hook in with the Android core plugins. And so, for example, the guys from Moneymo, I don't know who knows that company. This is a company that provides virtual devices in the cloud, right? And so if you write a single line, apply plugin Moneymo, what this plugin does, it automatically rewires how the Android plugin executes the tests. It no longer looks for virtual devices locally, it automatically routes them into the cloud and executes them in parallel and gets the test reports back. So it's completely transparent with a one-liner, and this is because the Android core plugin provides so many hooks so that this other plugin can hook into the Android core plugin and rewire it and say, hey, the testing should, if you're using Moneymo, the testing should happen a little bit differently. Right? So it is very easy for the user to make use of the Android tooling automation system. So there are now plugins out there for Robo Electric, for Moneymo, for DroidCon. So initially, mostly from the testing providers, a lot of other good stuff is there to come. So there are a couple of generic concepts that are brought into the open by the Gradle Android plugin. So one interesting thing is the source to output mapping. So initially, Gradle, in Gradle you have abstractions to model logical group of sources, right? And initially in Gradle was always, hey, you have this group of sources, like some Java directory, and there is exactly one binary, one jar that comes out of that. With Android, this is now different. You have multiple groups of sources that should end up in one APK. And this is a similar concept we're now also using for our C++ support. So you have a logical group of sources, even from different languages. You have a group of C sources and a group of C++ sources that should end up in one binary. And of course, what we don't want you to do is that you have to do the wiring yourself. So we provide you very nice abstractions that you can assign binaries to different groups of sources without bothering about how the compile and archiving is actually taking place. Right? Another thing of the source to output mapping that comes also from the C++ world is that you have a logical group of sources, but you want to have multiple binaries like a static and a shared library, right? So this is a concept that was enriched by the experience with the Android plugin. The other very exciting concept is the concept of a variant. You see this all over the place, not just in the Android world. We just were at the client, and they had some 20-year-old legacy software stack, and then exactly the same problem. They had a main code base, and then they were shipping software to different banks. Some of the banks were using WebLogic, others were using WebSphere, different versions of those application containers, and they needed to have certain variations for all of those different application servers, right? It's exactly the same thing. There's a main code base, and then you have certain variations. Obviously, in the C++ world, this is a core concept, the idea of variants, right? And that is the next thing that is pushed by Android, is the idea of variant-aware dependency management. So stuff like so if you have different dependencies between libraries and applications in the Android world, we can use the variant information for smart conflict resolution. So we could always decide, this is the debug APK, so this debug API should also use the debug variant of the depending library. You shouldn't be required to specify that, right? And the same is true in the C++ world. So you can find automatically the affinities that the dependencies are assigned the right way. So this was kind of the modeling aspect of the Android plugin, but there are also more kind of deeper aspect why Gradle was chosen as a platform, and one reason is performance. So and Android builds can be heavy on performance, and there are many things that Gradle offers in regard to performance. So I will just pick one of the things we like in particular. It's the incremental build. So the example I'm showing now is not for an Android project, just it's for a normal Java project, but it's the same concept. Sorry, I have to go back. So here we don't say apply plugin Java, we say apply plugin Android, right? And we stick to certain conventions like the production code lists in source main Java, the test code lists in source test Java, etc. It's the same game as we're playing with the Android plugin. So this is a very short build script. And now we're using Gradle to execute the build. And we say Gradle, do a clean build. And everything is built. And the next thing, we're now saying don't do a clean build, right? And you see, everything is up to date, right? So now the question is, how reliable is that? So let's play around a little bit. Let's, for example, change a production class. Let's remove a field from a production class, and let's re-execute the build. And you see, Gradle has figured out, hey, the code has changed, so the jar needed to be rebuilt, the test needed to be re-executed because the class path for the test has changed, the production code has changed, etc. So we haven't saved much time here, but at least the incremental build works reliably. So let's do something else. Let's remove this comment. Let's say Gradle build. And now it's interesting. Gradle recompiled the sources, but the bytecode hasn't changed. So the jar is still up to date, right? It's the same bytecode than when you run it before. So therefore, everything is up to date. So that was a nice time saver, even for this very small project. And you can even change properties in your build script. So let's change the source compatibility version. And if you re-execute that, Gradle picked that up, and everything is rebuilt because the bytecode has changed. And the tests are re-executed. So you can also change the version of JUnit that you're using to run your tests and compile your tests. And this is also picked up. And you see everything is up to date until you come to compiling the tests, and that is where the tests are recompiled because the class path has changed. So it is sensitive in regard to the input. It is also sensitive in regard to the output. So if you remove, for example, a compiled class and you rerun the build, what you can see is the classes were recompiled, but the bytecode hasn't changed, right? So all the rest is still up to date. So an interesting question is now, how can you use that if you have custom build logic, right? So let's say you have some XML file, and the requirement you're having is you want to create, for every node of this XML file, for every mountain node, you want to create a text file where the name of the mountain is the name of the text file and the height of the mountain is the content of the text file, right? So let's create some logic for this in the Gradle build, right? So we create a task, generate mountain files, and we have some scripting logic that parses the XML file and creates the text files. We don't need to go into the details. Now, one thing that is very handy, you can do camel case task execution. Also for all the task names you've seen before. So if you say GMF, Gradle will find the appropriate task. In that case, generate mountain files. So, and if we now look, we need to refresh. There's now a mountains directory with the K2 text and the Mount Everest text. Don't bother about the numbers, they're wrong. So, and now the question is, if we execute this, I haven't changed anything, right? Will it be up to date or will it be not up to date? What do you think? I haven't changed anything of the input, right? And we are claiming Gradle as incremental build functionality, so let's see. Nope, Gradle regenerated the mountain files. It regenerated again. So what is going wrong here? Right? So we also have a company behind Gradleware, and incremental build for custom build logic is a commercial. No, it's not. There's something. So one thing we don't like here is we don't want to see too much scripting logic in our build script, right? Mixed with the declarative parts of the build. So what we do now, initially, we extract the logic into what we call the custom task. We call it convert mountain XML, right? And we specify the properties of this custom task, the XML file, which is the mountains XML file, the separator in the text file, the output directory, which is the mountains directory, and then we specify the task action, which is basically the same logic as above. And now we are changing this and say, hey, this task is now from type convert mountain XML, right? And we specify now the properties. So it's the mountains directory where the text files should be placed, the XML file that needs to be passed, the input file, and the separator. So, and if we now execute this build, let's do a clean build as a start, and if we now re-execute it, what you can see is, now everything is up to date. And how does it work? Well, let's first check whether they are still produced, the text files, yes. Let's change a number in here. Let's re-execute, and you see this change was detected. The mountains file were regenerated. If I execute it again, it's up to date. And you can, for example, also change the separator value. If you now look, this change in the property was detected, and the separator is now a semicolon. Right. So how does this work? Well, it's extremely simple. You just need to annotate the properties of your custom task. This is an input file, this is an input property, this is the output directory. That's all you need to do. You don't need to tell Gradle anything about incremental build or whatever. Just what are the input and outputs of your task, and from that Gradle can do all the smartness that is necessary to provide you with an incremental build. But it also provides you some other logic. For example, you get automatically validation of your input values. So if you specify this check, you don't need to code in your custom task. It is automatically done because you specify the property as an input value. Okay, so there's another thing that came out of the Android effort. Initially, the incremental build functionality in Gradle was a binary functionality. So Gradle was telling a task either nothing has changed, so you don't need to do anything, or something has changed, so you need to redo everything, right? It was a binary thing. And what we added as part of the Android cooperation, there is now an API. So if you write a task that can be very smart if stuff has changed, you can now ask Gradle when the incremental build figures out, the generic incremental build in Gradle figures out something has changed, it passes you the information of what exactly has changed, of what exactly was removed since you last run the build, and then you can be really smart and say, okay, I only need to regenerate the stuff that has changed, right? Yeah, another thing we're doing for the performance is the Gradle daemon. The Gradle daemon is a long-running process so when you use Gradle with the Gradle daemon, a long-running JVM is created with a warmed-up Gradle, and when you execute the build a second, third, or fourth time, the responsiveness will be much better. So that's especially when you work with dynamic languages that need some warm-up time. That is a very important feature. Okay, there's some other reason why Android choose Gradle for the Android build system is that it's already a platform, like the incremental build, that provides a lot of interesting services. And I want to show you one of those services that is pretty cool, and I guess most of you are using as soon as they're using Gradle. So in Gradle we have the concept of a wrapper. So for any Gradle build, Android, Java, whatever, you can specify a wrapper task. It's a one-liner basically. In the latest version of Gradle, you don't even need to specify it in the build script. It's automatically available. And you, let's say as the build master, you can do the following. You can execute this wrapper task, right? And what the wrapper task does, it creates a couple of files in the root directory of your project. Gradle W, Gradle WBAT, and a directory, Gradle wrapper, with the Gradle wrapper jar, which only has a couple of kilobytes, and Gradle wrapper properties. And and what you're doing with those 4 files, you're committing them to version control, right? And the next time someone checks out from version control and wants to build this project, this person doesn't need to have Gradle installed. This person can just use the Gradle W scripts, right? And then Gradle will be automatically downloaded for them with the URL specified in the Gradle wrapper properties file, and the build will work, right? And the next time, of course, Gradle won't be downloaded another time because it's in a local cache. So if you want that all your team is upgrading to a new version of Gradle, you just change the distribution URL, commit it to version control. The next time some of your developers do a checkout and run the build, they will automatically pick up the newest version of Gradle. So you have zero administration on the client side. That's one aspect of that. The other aspect of that is historical builds, reproducible builds. So we have clients in the medical industry, and I guess that is Android will more and more enter also, I think, mission critical areas. They get auditing, I don't know, once a year, and if they can't show that they are able to reproducibly build their software, they have to call back all the medical devices they have sold to the hospitals. They are no longer allowed to have them in use. So for them, reproducibility is a mission critical aspect. In financial industries, there are sometimes similar requirements. So, yeah, it depends on the domain whether this is an interesting feature or not, right? But in any the reproducibility aspect of it, in any case, it's very convenient in whatever domain you're working with. So. Another thing that is interesting is the concept of init scripts in Gradle. So if you have multiple projects that share similar configuration information, like here we have a project that is called Testing with Gradle, and we specify the location where to retrieve the dependencies from. What we did now, we removed that information, right? And we now created an init script, what we call an init script, where we put that information in. Get your dependencies from Maven Central. So what we can do now on the command line is we can say, hey Gradle, run this build. And this build would fail without, if we wouldn't specify the -i init script, the build would fail because it wouldn't know where to get the dependencies from. But with this init script, you can inject this information into any Gradle build, right? So, and the build works and runs the test. So, and one thing I want to use to show you is Gradle is extremely customizable. You can put amazing stuff into the script to do really deep customization. So, for example, let's assume what you want to do is, hey, I want to issue a warning to my developers if any of their tests is taking longer than 20 milliseconds, right? So how would you do that with, I don't know, with other build systems? With Gradle, you can do it the following way. You can say, in the init script, hey, give me the Gradle object, which represents the build runtime, and then you say, hey Gradle, after you have evaluated all the projects, give me the root project. In the simple builds we have seen so far, there's only one project. There is only a root project, but you can in Gradle have multi-module builds where you have multiple projects in one build. And then you say, iterate over all the projects, and for all the test tasks, I want to hook in a listener into the test task. So that listener is called after test. So Gradle now calls this hook after it has executed a test method, right? And it gives you the results, and you can then calculate the time it took to execute that test. And if the time is greater than 20 milliseconds, issue a warning. Okay. So let's see whether this works. And here we go. In real time, you get the warnings that the tests are long run, right? With a few lines of code. And you can do interesting stuff. You could, for example, say, I want to let the build fail if the tests are long running, but I only want to do this on continuous integration because there I have a defined environment, right? You can use this injection principle that you inject additional behavior depending on which platform you're running, either a local build or a continuous integration build or the build that is supposed to go out, is the release build. That gives you a lot of flexibility, and the example shows how deep you can into the guts of the Gradle runtime to get information, to add behavior, etc., etc. We had a user that, and now we have multiple users actually. They have a lot of problems with fragile integration tests, and they had a couple of very important integration tests, and the rule for them was, if they fail the first time, it's okay. If they fail the second time, then it's considered a failure, otherwise it's considered a success. You can now laugh about this company, right? But it's a hard problem sometimes to solve. One of the team members there was Stefan Faber, the founder of Mockito. You don't have to tell him about about testing and being a smart developer. They couldn't change it. Also for the reason that it was a different team, it was related to infrastructure. So those are sometimes the reality you run into in enterprise. You can say this is not a good situation. Well, we all know that, but hey, that doesn't help you in that moment. You need a tool that is humble and say, okay, I give you a toolkit to solve that. Don't ask us to put in the Gradle API a new method, succeed after 2 failures or something like that. We wouldn't do that. That is, your pathologies won't pollute the Gradle API, but you can use the toolkit to solve this problem. And there's so. As soon as you're in a more complex delivery scenario, there's always unanticipated stuff happening, and you don't need a tool that thinks it knows how the world looks like for you. You need a humble tool that provides you opinions, out of the box behavior, but when you really need it, it must provide you a toolkit to solve your custom problems, and at least not stand in the way, and even better, it should make it very efficient for you to solve those problems. So, and this goes one step further, this concept. What you can do now with this init script, you can now go to your local Gradle distribution, right? And every Gradle distribution has an init.d directory. And in this init.d directory, you can put an arbitrary amount of init scripts, right? And we're doing this right now. And if we now run this project, we see this init script is now automatically applied. You can now argue with good reasons, I don't want to mess around with my local Gradle distribution, especially if people use the wrapper, they don't even know where it's located, right? So, but this is now the interesting thing. You can use the Gradle wrapper and can let the Gradle wrapper point to a Gradle distribution, right, on a shared network drive, on your binary repository manager, with init scripts that pre-configure your local build environment. You get the idea. And then when the developers use the Gradle wrapper scripts, they automatically download the Gradle distribution with your init scripts, where you can do all kinds of stuff. You can redefine where to get the dependencies from. You can specify rules. You can whatever you want, right? With the deep API that Gradle provides you. So no build wikis. So developers have to read how to set up the local build environment. It will just work. So the init scripts and the init.d directory in conjunction with the wrapper is a really, really cool feature, and yeah, much appreciated by especially by the enterprise users. Okay, yeah, you can also nail down other aspects of your build environment. The JVM arcs used by the Gradle build tool, or which Java version needs to be used. So you can put this also in version control. With other build tools, you have to create an end-ops or maven-ops environment variable, which is global, and which is not in version control, which you have to describe in a build wiki. Every developer has to set that environment variable. In Gradle, you just put a Gradle properties file in your project, and those properties are defined, they are version controlled, and the developers don't even need to be aware of them. Okay, another interesting aspect of the Android plugin is the deep IDE integration. So what is that about? A major thing the Android folks wanted to resolve is that they basically had to maintain for Android 2 build systems. One was the Ant-based build system that you would be using on a continuous integration machine. The other was the build system they had to provide with the ADT tooling. 2 different build systems, right? Because the IDE was not delegating to any build system, it was doing the build action themselves. And that is this is problematic and not very, has a lot of problems for multiple reasons. So one is, and if you let the IDE don't do any build actions, but the IDE would reach out to the build system to do whatever needs to be done, compiling, dexing, testing, etc., then you still have the richness of an IDE, but the feedback you get from the IDE is close to the canonical build that runs on continuous integration, right? Separate jobs for different build variants depending on how long the tests are running or how many tests they have, right? We will provide you, like for the IDEs, a model for Jenkins that you can, in very smart ways, programmatically script the job setup in Jenkins. Right? That's really cool stuff, I think. And so, yeah, talked about that. So this is work in progress. So we started work on that together with the Jenkins guys, and Android again will be leading the whole movement. So for the first platform we implement that for won't be Java, it will be Android. Okay, so this is the last content slide. So the deeper mission of Gradle is related to the fact that we see a lot of suffering with any kind of medium or large-scale software stack in regard to missing automations. We see projects that have build times of 8 hours or 14 hours, distributed teams that hardly ever get back to a state where everything works together and all the components can build together. So a lot of waste because of wasting time, because QA gets crappy versions all the time, and they have to wait another day until the 4-hour-long deployment, is done for a new version to try again. The continuous delivery domain at the moment is the domain full of suffering. And when I talk about theoretical versus practical freedom, theoretically you could solve all those problems, right? And even with Ant, although it will be hard. But there are only a few companies in the world that have the skills, the resources, and the backing from management that they can really achieve what is theoretically possible for a really good continuous delivery pipeline. Google is one of those, right? But they are not many. And for the majority of the companies, what is theoretically possible is just unachievable because they don't have the skills or the resources to implement that with the legacy tooling. And the job of Gradle is basically to enable the big majority of the companies to get much closer to the theoretical possibility of a very strong, powerful, fast, continuous delivery pipeline, as I said, with reasonable effort. There will always be effort involved. Modeling continuous delivery for any organization with more than 50 developers is a challenge, right? You're modeling an organization at the end of the day, how they cooperate, how they release, but with reasonable effort, that is our goal. Gradle provides you the toolkit that you can really push your automation to the limits. So Gradle is not so much about the cookie cutter solutions. Gradle provides cookie cutter solutions, right? We've seen some of the examples, but this is rarely what an enterprise needs. There are always customizations you need to do, always special behavior, special problems, and Gradle is the toolkit that you can use to solve those. If you want to learn more about the new Android build system, there is very decent documentation on the Android tooling website. If you want to learn more about Gradle, go to gradle.org. You can also subscribe to our newsletters and notifications if you're interested. We also offer trainings for Gradle and for Gradle Android, and at the end of the day, Gradleware is the company behind Gradle. So we know a lot about Gradle, but we also know a lot about continuous delivery as a whole. So if you have questions, if you're struggling, if you want to improve your continuous delivery pipeline, go to our website, fill out a contact form. We are more than happy to help you with our experience. We are involved with some of the largest software stacks in the world, but also with many smaller companies. All of them can benefit a lot from improving the delivery pipeline, and we can help you with our experience and our skills. That's it. Do you have any questions? Yes, please.
I really like the idea of using a simulator tool to test with, and you said that's coming. Is there any time frame for that? And also, I didn't hear anything about being able to test on devices. pushing out to devices?
Okay, so this is already available for Testroid. They have released their first version of the plugin, and the Manimo folks. So this is, and I think the first Rover Electric plugin is out there. I don't know about the quality, but this is already available. Sorry, the question was, I talked about this additional Android plugins in the testing domain from some of the testing providers. When they can be used, and I said this is already available stuff. They're working on it. It will be improved, but it's already available. You can at least spike it and see in how much it solves, does what you want. The other question was how with the Gradle Android build system you can work with actual devices. It's easy. You have install tasks, you have uninstall tasks. You can easily so the build tool checks which devices are available and then pushes to them.
Same day,
Right. So this is kind of a hybrid talk by design. So there's a really good talk from Xavier Ducouré. He presented the build system at the Google I/O conference with more details than I did here because I had a mixed approach. So that's different. It's available on the Android webpage and on Google I/O channel. So this is also where you can learn more about some of the stuff I've mentioned. Yes, please.
I deal a lot with Ant scripts and trying to debug those and track down like which targets are defined where, and the properties is kind of like a pain. Is there an easy way to debug Gradle scripts? Is there IDE that really like makes it easy for you? You can click and go to the target definition and so forth.
Yes, you can debug on the source level. I mean we do this all the time, and you can do that. No, there's no problem. There's still some. So and sometimes and often it's easy to hunt down a bug. Sometimes and that's one area we're investing in. It's a little bit harder with debugging. You always can find the cause, but we want to invest quite a bit of effort over the next 6 months. That in most of the cases the error message should give you a good hint what is going on. This is sometimes still a little bit cryptic at the moment, but yes, you can debug. There was a question in the. I saw a hand before somewhere. Yeah, please.
Okay, so if you're importing a module from like Maven Central,
Yes.
and let's say it's like ActiveR Share one, but
Yep.
it includes an Android manifest file, and Gradle refuses to compile because now there's 2 Android manifest files. Is there any?
Yes. So so I think you're talking about the old kind of Maven library format, right?
Go ahead and repeat the question, Hans.
Okay, sorry. There was a question how Gradle works together with the Maven Android library format. Basically, that's a feature added in master of the Android plugin. So the next release should make this work without problem. So yeah, many people ask for that because they said, hey, basically I can't use it because I can't use those libraries, and yeah, so that is solved. It was one of the I would say #1 complaints about the current state of the build system. Yes.
Is there support for Atlassian Bamboo with Gradle?
Yeah. So is there support for Atlassian Bamboo with Gradle? Yes. So Gradle works with any CI server. Some have a richer integration, some not so rich, but the main job you can do with any CI server.
What about, so you showed us, you typed Gradle task and it showed a bunch of tasks.
Yes.
Now, how many of those were out of the box and how many were defined? Like, so it was per project, right? It was for Android. What is the difference between the Android task and the Java task? Like, they're all just comes pre-bundled with
Yes,
Gradle?
yes, there was nothing. It was just a few lines of code. There was nothing, no custom logic under the hood. That all came from the Android plugin. There was nothing to be done on my side.
If you're not using Android plugin, you're just using regular Gradle.
So if you're using a Gradle plugin, then you would get, if you're using a Java plugin, then you wouldn't get all the Android tasks. So you would get a life cycle for a Java project, right? And they share some of the life cycle phases, like the concept of assembling, of compiling, but the Android life cycle is much richer. And you can easily work with mixed project in Gradle. You can have a multi-module build with with a Java backend service, with an Android application and all that. So that is one of the strengths of Gradle, that it can provide you a unified view and a unified build process, even if you're using very different platforms. Yeah, thanks a lot for your attention. I really enjoyed it.
So you can stop the live stream now. So what we usually do at the beginning is give a chance for announcements. So since you made it to the end, I had one or two people who I didn't give a chance to do announcements. So if they come up here now really quick, and then what we like to do is give you a chance to, those of you who stay patiently at the end, to talk to the speaker. But let's get the quick announcements first, and then we'll do that.
Thanks, man. I'm Gopal. Oh, sorry.
Please go close.
Okay. I'm Gopal. I normally come here to learn more of the technologies and also do networking. I have a good news to share. Right now I work for a company called lendingclub.com. So it's a peer-to-peer lending, and we are growing really exponentially. So we took in our platform, we took 5 to 6 years to fund the first $1 billion. The next 7 months we reach a second $1 billion.
So you're looking for developers?
So we're looking for
What kind of
developers,
developers?
Java developers and the QA engineers.
Okay.
If anyone have interest or know any of your friends, you can just talk to me.
Come and talk to him before you leave. You're looking for Java QA.
Hi, my name is Suyash. I run the Bay Area Android Study Group, and we have a meetup coming up next week. Chuki Chan, she's like an Android expert, going to talk about how do you handle device fragmentation and all of those bugs that come with it. So it's on Wednesday, July 17th, Bay Area Android Study Group. I'll put a link on the meetup.
Put it on a comment on tonight's meetup for everybody here in the series. All right, so that's it. And now we can stay here for a few more minutes. So if some of you want to go up and talk to Hans personally, I'm sure he'd be happy to talk to you at least for a few minutes before he has to go.